If you're working in the GIS industry, then you're probably familiar with geoprocessing. In this video, we'll count down the top 20 GIS tools that every geospatial analyst should know. Let's get this show started. Starting with number 20, we have viewsheds. Viewsheds give you a detailed picture of what can be seen from a particular point. This includes everything from buildings to bridges and other landmarks. Urban planners, developers, and landscape architects use them to assess the visual impact of development proposals or analyze the scenic qualities of an area. At number 19, we have the zonal statistics tool. Zonal statistics helps summarize the characteristics of a geographic region by dividing it into smaller zones. It extracts statistical data from a raster layer based on the boundaries defined by a vector layer. For example, zonal statistics can be used to calculate the average population density within each administrative district of a city. At number 18, we have the least cost path tool. The least cost path identifies the optimal path between 2 points based on the cost of traversal. This technique takes into account the terrain, obstacles, and other factors that affect the ease of movement across the landscape. You can use it for everything from pipeline routing to planning a ski slope. At number 17, we have the APPEND tool. This tool allows users to merge multiple datasets into an existing dataset. It is commonly used to combine 2 or more tables, feature classes, or shapefiles with similar attributes. But it's also possible to use field maps if the columns don't match in all the datasets. At number 16, we have the line of sight tool. Line of sight determines the visibility between 2 points in a geographic region. It accounts for elevation, buildings, and obstructions to understand if that pathway of vision is visible or non-visible. We use the line of sight tool in fields such as urban planning, military operations, and telecommunications. At number 15, we have the MOSAIC tool. Mosaicing allows you to merge multiple raster datasets into a single seamless image. This tool is useful when working with data that has been collected over different locations and needs to be combined into a single raster dataset. It offers options for handling overlapping areas, such as blending or feathering edges to create a more seamless transition between rasters. At number 14, we have the Union tool. Before you use the Union tool, make sure you understand how to use it. Not only can it be a bit tricky, but the output can also get a bit messy. The Union tool combines input data layers into a single composite layer, but the main difference is that it preserves the boundaries and attributes from all input features. At number 13, we have the RESAMPLE tool. Raster resampling changes the spatial resolution of a raster dataset. We often use this tool for merging or overlaying raster datasets with different resolutions, but we can also use it for preparing data for different types of analysis that require a specific resolution. At number 12, we have the raster clip tool. This tool extracts a portion of a raster dataset based on a specified geographic extent. It's useful when working with large raster datasets that cover a larger area because it can reduce the size of the input data and focus on the specific area of interest. At number 11, we have the erase tool. This GIS tool is like an eraser in a way because it completely removes any features to a specified polygon extent. For instance, you may use it to erase forest cover after a wildfire. Overall, the erase tool helps refine the input data and has its applications in areas such as land use planning and natural resource management. Okay, we're halfway finished with our list of geoprocessing tools. At number 10, it's the raster calculator tool. The raster calculator allows users to create new raster layers by combining or manipulating existing raster layers based on a user-defined equation or expression. Some people also call this geoprocessing tool raster math or map algebra. No matter what you call it, it's a must-have for terrain analysis, image processing, and remote sensing analysis. At number 9, we have interpolation. Interpolation refers to the process of estimating the values of unknown points within a given set of known data points. There are various interpolation methods, including kriging, inverse distance weighting, and spline interpolation. But each interpolation technique has its own strengths and weaknesses, depending on the data and application. At number 8, we have the spatial join tool. This tool combines spatial data from 2 or more layers based on their geographic relationship. For example, it could be based on their proximity, if they intersect, or even if they're identical. Overall, the Spatial Join tool is useful if you want to merge attribute data from one layer to another based on the spatial relationship with nearby features. At number 7, we have the Dissolve tool. Dissolving in GIS means that it fuses adjacent polygons into a single feature based on similar attribute values. For example, you can dissolve all 48 U.S. state boundaries into one contiguous United States feature using this tool. Overall, the Dissolve tool is useful for simplifying and aggregating data to create a more generalized geographic representation. At number 6, we have Table Joins. When you join tables, it combines data from two or more tables based on a common attribute or field. It links data from one table to another based on a unique key that's present in all tables. Although it's certainly possible to join tables with spatial data, you can also join non-spatial tables as well. We're at number 5 in our list of top geoprocessing tools, and we have the Create Contours tool. Creating contours is the process of representing the shape and elevation of the land surface using lines of equal elevation. The resulting contours can be used to create elevation maps, measure elevation changes, and analyze terrain features such as ridges, valleys, and slopes. At number 4, we have the INTERSECT tool. This tool can accomplish a lot more than you think. The main purpose is to combine two or more spatial data layers to create a new layer that includes only overlapping areas. One of the biggest benefits of this tool is how you can obtain attributes from both layers and build pivot tables from them. Additionally, you can use the INTERSECT tool to find self-overlaps. At number 3, we have the Merge tool. This tool combines two or more data layers into a single layer. It works by merging the attribute tables and geometries of the input layers, resulting in a new layer that contains all the features and attributes from the input layers. The Merge tool is also useful for managing large data sets and simplifying data storage. Alright, we're almost at the end of our list. At number 2, we have the Buffer tool. This tool works by creating a geometric boundary around each feature and expanding it by a specified distance. This results in a new layer that shows the areas that fall within the buffer zone. For example, it can help visualize areas that may be affected by a proposed infrastructure project, or assess the potential impact of environmental hazards on nearby communities. In our top spot at number 1, we have the Clip tool. This tool extracts a subset of a data layer based on the geographic extent of another layer. It's useful for creating smaller, more focused datasets from larger ones, or for isolating specific features or areas for analysis. This is the go-to bread and butter for GIS analysts, and certainly one you should have in your arsenal. Alright, there you have it. I hope you enjoyed our list of top 20 GIS tools. Is there anything you'd change from our list? Please let us know with a comment below, and make sure to subscribe and like our channel for more GIS videos.